Hello, everyone. It's Crazy Astrophysics Guy again. John Scott Cover, just here in my moment of zen. It is red letter day for me, and I'm celebrating, of course, with the panda. Love panda. The panda. Love their food always. So that's why I usually get when I'm celebrating something. I am celebrating because as of 2 hours ago, right around 2 o'clock in the afternoon, it is October 24th. It's on a Saturday. I submitted my resubmitted my first paper on the Cover sign and what that all entails. So the Cover sign is not a new discovery. Actually, it stands for the Coversed sign. It's been around since ancient Egypt, pretty much. It is an ancient math. The verse signs are all completely ancient. So, in my advocation of bringing back the verse signs, I started to look into cosmological concepts and was thinking that it could actually stand for something, which it actually does. I discovered that the Cover sign, I know a lot of people out there, especially scientists, know about the Schrodinger equation, which is for massless particles at higher speeds, or higher velocities, rather. And the Cover sign as an actual, I submitted the paper that it become an actual quantum wave equation as well, because the Cover sign works for all densities. Now, when you say all densities, yes, my dissertation was actually on density itself. So yeah, Hamiltonian fractals and chaotic scattering of passive particles within a topological vertices was actually the topic of my dissertation, which was in the realm of density, because and that's where I said that all mass has density, not all densities have mass. So there is that. That's my original interpretation in the dissertation itself. However, in looking at Sagittarius A star, which is the black hole in the Milky Way, in the center of the Milky Way galaxy, there is a dust cloud called Sagittarius B2. In Sagittarius B2, there was a lot that had taken on itself. We were looking at the molecular structure of the dust cloud itself. We did find that it does have chiral molecules to it. Propylene, actually, is what it is. CH3CHCH2O, which is the molecular chemical formula for propylene. And it does have the mirror images of a different molecule. It's actually an organic molecule, which paired with another organic molecule, it could mean extraterrestrial life in some places. I mean, take a look at our DNA structure. It's a chiral molecule itself. However, if you change the sugars and the bases itself, our biology may be completely different than anyone else's. So, yeah, even though it is an interstellar, I can't even talk, interstellar space, it actually has a property for it. So yeah, there's different chemicals goes along with different life, everything. And I'm talking genetically, I'm talking biomolecular, I'm talking about everything. So just wanted to let you guys know that. And I know the Cover sign has some other implications as well. And as far as if you guys have heard of relativistic mass, and I'm here with this, one of my whiteboards. If you can read that, it's E equals mc squared divided by the square root of 1 minus the sine, is what that is, 1 minus sine, which is v squared over c squared. which is actually V squared over C squared is an electromagnetic wave. It propagates. It's an alternate wave. So what I'm addressing here is that the energy equation that Einstein came up with has to be divided by the cosine itself. And that's important because when I tell you that time is irrelevant, or actually it's not really irrelevant, it's time is is not absolute. So, in as much as, especially when I'm talking about fusion of the stars, talking about fusion theory within stars, you have to have. And that's why it takes so long to get volume in a star, because whatever energy you create, well, actually, whatever any energy is changed into fusion, you have to divide it by the cosine. And that just makes it a lot more time to gain a mass. I'm also proposing, and I put this in my paper that I just submitted today to the Journal of Physics, that the cosine is also should be seen in quark-gluon plasma. It can also be with the Higgs boson for energy to transform into mass. So pretty much the mass equivalence formula. The cosine is also important there because you have to divide like I say, you have to divide all energy with the cosine. Otherwise, it won't work in as much as the description of what's happening during that transition. It is a transition stage. Einstein would probably be rolling in his grave if he knew that the cosine had something to do with that. When Einstein wrote his paper about quantum weirdness out in space, that's what the weirdness was. And I didn't just come up with this. I used the telescope at my university at the time. I was using it from the year 2000 to 2005. I had pointed it to the Sagittarius A star black hole, and actually discovered that before information going into a black hole occurred, there was a blip in the screen. And I verified that blip with over 40 filters. 40 filters, which took some time. First I did Doppler filters, then I did X-ray filters, had to do microwave filters, I had to do gamma filters, all kinds. And I discovered that I had seen that blip before. Lo and behold, it was 1 minus sine x. Instead of x, I usually use theta because theta is an angular propensity. So I always put 1 minus sine theta. It's a better transition. Like I said, better transition, better things with the angular momentum because everything is more than 360 degrees. It's actually, you shouldn't look at it, 360, 720, more like 1080 degrees, because the more 3D you get, the better propensity you have of looking at everything in nature. So yeah. My point is I'm actually celebrating because they were looking to. This wasn't just on the spur of the moment. I wrote this paper starting way back in 2012 when they discovered the Higgs boson itself. It's been a long time coming. Actually, I submitted the first rough draft in 2013. And that's when I found out that this blip was the actual cosine. So I hurried up and wrote a paper on it, submitted it. they had looked at it before. They had a lot of questions for me, of course. But like all research should drag up more questions than it has answers. So, which you're on the right track when you do that. But yeah. So yeah, that's what I wanted to come to you guys and tell you about. So yay, the cosine is an actual quantum wave equation. It is going to be along with Schrodinger's. Like I said, Schrodinger's equation works for Planck mass. Planck mass at a subatomic scale. We're talking about neutrinos, hadrons, all those massless particles before they become mass. The cosine works well with higher densities, meaning that it works with matter. It's not. It doesn't work well with massless particles. So you have a dual implication here of when to use Schrodinger's and when to use the cosine. But yeah, it is. It's awesome. I'm really happy. I hope this is not my only. I hope this is not the one and only contribution I have to science, but it's a step in the right direction. Kind of a baby step. And like I said, Albert Einstein would probably be rolling in his grave if he knew that the cosine had something to do with energy itself. So the energy mass equivalence formula. So hopefully I hear some good news about that. So the Journal of Physics is really excited for it as well. They've been calling me wondering what's going on with it. So I actually submitted it today. So it's something to be beheld. So I just wanted to let you guys know, and love you guys. Thank you for following me, and thank you for everything. So like I always say, live 5 iterations above the norm, and hope you guys have a great day. All right, thanks. Bye.